Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In this session, we are going to see about the types of fuel. We have already seen in the last session about the CNG and LPG. Now in this video, we'll see about the power alcohol and biodiesel. So power alcohol, when ethyl alcohol is blended with petrol at the concentration of 5 to 10%, it is called as the power alcohol. In other words, absolute alcohol, 100% ethyl alcohol, is also called as the power alcohol. Ethyl alcohol is used in an internal combustion engine. The addition of the ethyl alcohol to petrol increases its octane number. When ethyl alcohol is blended with diesel, it is called e-diesel. How to manufacture the power alcohol? It includes the following step, that is, first is the manufacture of ethyl alcohol. Ethyl alcohol can be synthesized by fermentation of the carbohydrates. Fermentation of molasses, which is the residue left after the crystallization of sugar with yeast, generates alcohol. This fermentation yields only about 20% of alcohol. Okay, so in this reaction we can see that the glucose in the presence of yeast gives ethyl alcohol and carbon dioxide. Concentration of alcohol can be increased up to 97.6% by fractional distillation yields by rectified spirit. The concentration of alcohol cannot be increased by distillation above 97.6% because it forms a constant boiling mixture with water. The constant boiling mixture has a lower boiling point than alcohol. Step 2. Conversion of ethyl alcohol into power alcohol. 100% alcohol, that is the absolute alcohol, is prepared by removing the last traces of water from the rectified spirit. It can be done by the following two methods. Alcohol containing traces of water is distilled with benzene. When the benzene passes over with a portion of alcohol and water, it leaves behind absolute, that is nothing but the power alcohol. Alcohol is distilled in the presence of dehydrating agent which holds the water. Finally, absolute alcohol is mixed with the petrol at concentration of 5 to 10% to get power alcohols. Properties. Power alcohol has a low calorific value, 7000 kilocalories per kg. It has high octane number, that is 90. Its anti-knocking properties are good. It generates 10% more power than the gasoline of same quantity. Its compression ratio is also higher. It's used as very good fuel in motors. So what are the advantages of this power alcohol? It's actually cheaper than the petrol. If any moisture is present, power alcohol absorbs it. As ethyl alcohol contains oxygen atom, complete combustion occurs. So emission of carbon monoxide, hydrocarbon particulates are reduced. Disadvantages. Has the calorific value of power alcohol, 7000 calorie per gram, is lower than petrol, that is 11,500 calorie per gram. Specially designed engine is required. Output power is reduced up to 35%. Due to its high surface tension, atomization of power alcohol is difficult. Power alcohol as a fuel causes starting trouble. It may undergo oxidation to give acetic acid which corrodes the engine parts. As it contains oxygen atoms, the amount of air required for the combustion is less. The air required is less, so the engine and the carburetor need to be modified. Next is the vegetable oils. So these oils comprise of 90 to 95% triglycerides with small amount of diglycerides, free fatty acids, phospholipids, etc. Triglycerides are esters of long-chain fatty acids like stearic acid and palmitic acid. The viscosity of vegetables oils are higher. The molecular weight are in the range from 600 to 900, which are about 3 times higher than those of the diesel fuels. What are the problems that we face using the vegetable oil? There are certain problems, or you can say the disadvantages of using the vegetable oil. As the viscosity of the vegetable oils are high, atomization is very poor, and hence inefficient mixing of the oil with air leads to incomplete combustion. Oxidation and thermal polymerization of the vegetable oil cause deposit formation. Their high viscosity causes misfire and ignition delay. Their higher volatility and consequent high flash point lead to more deposit formation. The use of vegetable oil as direct fuel requires modification of the conventional diesel engine design. How we are manufacturing the fuel from these are, that is, trans-esterification or alcoholysis process, that is the problems of the vegetable oil overcome by reducing the viscosity. The process is known as the trans-esterification or alcoholysis. Alcoholysis is the displacement of the alcohol from an ester by another alcohol. It involves treatment of vegetable oil. The vegetable oil may be the sunflower, palm, soya bean, mustard, etc., with the excess of methanol in the presence of catalyst to give monoethyl esters of the long chain fatty acid and glycerin. It is allowed to stand for some time and the glycerin is separated. So alcoholysis reaction is represented as shown in this equation. The triglyceride in the presence of the alcohol gives glycerol and methyl esters of fatty acids. These methyl esters of fatty acids are called the biodiesel. So methyl esters of fatty acid thus formed are called biodiesel. Biodiesel is defined as a monoalkyl esters with long chain fatty acids derived from vegetable oils or fats. It is a pure fuel before blending with the conventional diesel fuel. Biodiesel can be blended with the petroleum diesel. So there are certain advantages of this. The biodiesel is biodegradable. It is prepared from renewable sources. The gaseous pollutants are lesser as compared to the conventional diesel fuel. Biodiesel can be produced from different types of vegetable oils. Best engine performance and less smoke emissions are achieved. Disadvantages: biodiesel gels in cold weather. As biomaterials are hygroscopic, biodiesel can absorb the water from the atmosphere. Disadvantages: biodiesel gels in cold weather. Thank you.